Okay, so today's lesson is on multiplying and dividing monomials. So monomials are one term, and we're going to use our algebra tiles to help us. So if we have, real quickly with our algebra tiles, back when you would say, oh, 3 groups of 2, 3 times 2 represents 3 groups of 2. So to draw that, it represents 6. And you guys know that. So we're going to go 3 groups of 2. And so there's 6 1 tiles. And out here you would have the 3 groups down the side. So there's your 3 tiles. You'd multiply it by 2 tiles. And so you get a total of 6. So there's your 3 groups of 2. Here's 1 group, 2 groups, 3 groups going down vertically. Okay? What we're looking at is we're looking at the area. Area is length times width, and we're looking at the rectangle that is created by the length times the width. In our case, it was 3 times 2. If I was going to do 5 times 3, then I would have 5 going down, 3 going across. And they're all nice perfect squares. So this is 5, this is 3. How many squares are there? 15. Okay. Now with our tiles, we have to use our rectangular tiles, our x's. So this 3 times 2x represents 3 groups of 2x. So what we have is we have a little multiplication T, I don't know what you'd want to call this thing. It's just a little guide to help us. So what we're multiplying, we can put on the outside. And we did that up here with these blue tiles. We put them on the outside and multiply them to create the rectangle on the inside. So this outside 3 we can put here. We'll draw 3 1 tiles. Go ahead and do that. Then what we're going to do is draw the 2x up top. There's 1x, there's 2x. So what we have to do now is create the rectangle that's created by these 2 multiplying by each other. So you can actually trace the lines. Now technically this red line's right on the black line. I just leave space so you can see it. And there you have the outside of the rectangle that's created. Now you can trace the lines on the inside. So there's the 2x's up top, which means I'm going to have 2 groups going down. There's my 3 on the left, which means I'm going to have 3 groups going across. 1, 2, 3 groups going across. Now they should all be the same. Of course I suck at drawing, but too bad, so sad. You have to represent them as if they're all equal. So what's the answer? What have we just created here? 6x. So the multiplication statement is 3 times 2x equals 6x. These are our factors, and this is the answer, the multiplication, which in math we call product. Okay, so factors and product. Any questions? 1. Okay, so the next question we're going to do is 2x times 3x. So again, the factors are located on the outside. It doesn't matter which one goes where. What would you like on the left side, 2x or 3x? 3x. Sure, keep it simple, I like that. So we can draw 2x, 1, 2, then up top must be 3x. And now I'm just going to use different color. You can create the product. So I always start, it's easiest for me, and probably you as well, to just first of all draw the outside of the rectangle. So this is the complete area, and to help us figure out what goes on the inside, we can trace the lines. There's 3 groups, and here's 2 groups, And so altogether, that's the area created. Now, my drawing doesn't really look very nice, but what is that? What's represented there?
6x.
6 what?
X.
6x squared. Okay, so this is 6x squared. And we're getting that by going x times x. It's creating this square area. So the multiplication statement would be 2x times 3x equals 6x squared. That's different than adding. When we're adding or subtracting, we don't change our x's. X's are x's are x's are x's. They never change. But here, when we multiply, x's become what, Ryan? X squared. Pay attention. That's on the video now. Good job. Everyone's going to hear that next block in the afternoon. All right. So we're going to get x squareds. Any questions? Okay, let's try the next one. Now we have y's. The only difference between an x and a y is y's would be a different length, but they'd still be a rectangle. So let's just make them a little bit shorter. What do you want to put on the left side? The 5y? So there's 1, 2, 3, 4, 5. So they're a little bit shorter than the x's. And what do you want up top? -2. You know, I didn't have to make them so narrow. I don't know why I did. Probably because I'm incompetent. And there's my -2y's, and they're shaded because they're negatives. So for my product, I'm just using a different color so you can see it easier. Again, I trace the outside of my rectangle that's created. And then I can split it into the groups. So I can go split down the middle to represent the -2y up top. And then for the -5y, sorry, the positive 5y's, I can split it this way. And now those are supposed to be y squareds. Should I shade these or not? What do you guys think? Why?
Negative.
Negative tiles times positive tiles will give me negative answers. So they should all be shaded. And they should all be perfect squares. How many do you have? -10 y squared. Okay? And so we can write the multiplication statement. Here we have the two factors equals -10 y squared. Any questions? Yes? If there are 3y, so you're talking like maybe 5y times 4y times 2y. Well, we can't use our algebra tiles for those. We'd have to just do those algebraically. We'll talk about that in a second.
What equal y?
This would be 5 times 4 is 20 times 2 is 40. Y times y is y squared times y is y cubed. So we can't make cubes from our tiles. Okay, but we're going to talk about that when we go down below. Okay, any other questions? Okay, the next one is the money question. It's a little bit harder. It's going to be the hardest you're going to see for today. -4x. Can we draw that? Left side or top? Left, because I didn't want to listen to Sean. So left side, -4x. There's 1, 2, 3, 4. And we should shade them all in. Oh, so pretty. And up top, we have to draw y's. Now, what do we know about our y's? Are they the same length of x? No. They should be the same width, though, but we're going to draw them a little bit shorter. Now, I'm going to try and overemphasize that a bit. So there's my -3y's. So now when I draw this, I'm going to do the exact same thing. I want you to fill it out, please. Okay, by yourself, you fill it out. Okay, so trace the outside. Then you can trace the lines on the inside. And if you overemphasize the difference between the x's and y's, you can clearly see that you're getting rectangles, x and y rectangles. Okay, should we shade those all in?
No.
Why?
Because there's two negatives.
Yeah, a negative times a negative will give us a positive answer. So how many rectangles do we have? 12, they're positive. And what should we do about the letters? What's the area of those? XY rectangles. So we can write that up top as well in a multiplication statement, 12xy. Okay. Any questions? Are those squares? Nope, so they can't be, okay? It's just x times y. One's length x right here, and the top is length y right there. Okay? Any questions? Okay. So we're going to now, Sean brought up a good point. What about if you have something else? So if you have something else, you're just something larger, then you're going to go and multiply without tiles. So when we multiply without tiles, we multiply our coefficients. I think you guys are seeing that. The numbers in front get multiplied. And we multiply our variables. Variables is that fancy math word for letters. Okay? So, key thing to remember with the letters, what happens when we multiply x by x? We get x squared. Okay? So when the base is the same, or the variable is the same, we add our exponents. Okay? Now I'm going to give you some different examples here because I don't like the ones I gave you. This is kind of more work for tomorrow. Let's just scratch out that plus 5. 9x times 3x, what did we do? We went 9 times 3 and x times x. So we got 27 what? Yeah. Add your exponents. x1 plus 1 equals x squared. So we got 27 x squared. Okay. Any questions? Okay, so next one. Let's just try this. 5x times 7x. Go. Who's got the answer? Go cute. 35x squared. Good. What if you have something squared? So it's 4x squared times 2x. What could that be? Yep, cubed. So how many cubed though? 4 times 2? 8. 8x cubed. Not 8 cubed, but 8x cubed. Oh boy. There you go. Any questions? So, I'm just going to give you a couple more examples here. Let's go 2x times positive 3. And then we're going to go 2x times negative 5. Okay. So multiply these two together. Multiply those two together. And remember they're connected by an addition sign. So up front, you're going to get negative 6x. And at the back, you're going to get negative 15x. Then we can add them together at the end. So what's negative 16 plus negative 15? Negative 21x. So you'll notice when we're adding, we're not making x squared. So we're just telling us how many x's there are. They don't change. Okay? All right. Any questions about multiplying? Cross that question off. All right. So what we're going to do now is work on the opposite. We're going to do dividing. Okay. But I don't like any of those questions. So let's go 2x divided by 2. So we're going to have to draw that. So what we have to do is we're going to have to draw 2x on the inside. So somehow we have to have these 2x's, but we have to divide them into 2 groups. How can we do that? So what we have to do, it's easiest for division, is to put the which is the divisor on that side. So how can we arrange those x's into two groups? Well, one on top of the other. So they match up lengthwise with the 1 tiles. So the 1 tiles, whoops, undo that. The 1 tiles should be paired up side by side so that the widths match each other. And so what is our answer up top? What's the answer to 2x divided by 2? 1x. Okay. So this equals simply x. 2x divided by 2 equals x. Okay. So what we're going to do now is we're going to divide 10x squared by 10x. So we have our little upside down L. And so somehow we have to arrange 10x squareds so that we're dividing it by 10x's. So there's 1, 2. Oh, that's a lot of drawing, isn't that? 3, 4, 5. Let's change that number. That's ridiculous. Let's go 5x squared divided by 5x. Much better number. Sorry, folks. But it's just going to make it easier on you. So let's write the 5x here. It's 1, 2, 3, 4, 5. So how are you going to arrange those squares? There's 5x squareds, and so your answer will be at the top. It's simply x. Okay. So for your division statement, we'll say 2x divided by 2 equals x. 5x squared divided by 5x equals x. Any questions? Okay, so let's play around a little bit without tiles. Okay, without tiles. So without tiles, we divide, let's go 12x squared divided by 3x. We divide our coefficients. And then we divide our variables. And for our variables, we're looking to subtract exponents. So what's 12 divided by 3? 4. X squared divided by x. Simply x. Okay. Let's go 25x cubed divided by 5x. Go ahead, complete that. Wait, what's the answer? 5x squared. Okay. So that's perfect. That's all we need to do. Just get the basics. Remember that these are all areas. It's length times width. If you're working the other direction, if you took your area and divided by width, that would equal the length. Or took the area divided by the length, that would equal the width. So working backwards, if you have the area, you do a division to find the other missing measurement. Just like adding subtractions for the perimeters that we did. Okay. Any questions? Your homework, page 259. It's listed on your unit outline. Please do the correct numbers. You should have no homework. You also have Chapter 5 review. So we're adding that in. It's reviewing, adding, subtracting. Okay. All right.